Welcome to Lab 4, Magnetic Braking with Faraday. So the purpose of this lab is to observe and explore the interaction between the falling bar magnet and the tube of aluminum foil in this experiment. So through this experiment, we will collect observational data of a magnet falling through a conductive tube of aluminum foil. We will model the magnet-tube interaction computationally, and we will compare the computational predictions with observed data. So for the background, some important concepts are Faraday and Lenz's law, the Biot-Savart law, magnetic flux, magnetic force on the wire loop, Newton's second and third law, and Ohm's law. So for this experiment, the system was found to be the magnets, and the surroundings were everything else, including the aluminum foil. So the assumptions here are that air resistance when the magnet is falling is negligible, and the north end of the magnet is pointing down when falling. And finally, that aluminum foil is non-ferrous, meaning that it does not interfere with its own magnetic field. So for the setup, the magnet is held above the tube and no forces are acting on the system. And the procedure is that you drop the magnet with the north pointing down towards the aluminum foil and record how long this takes, and then repeat those steps 1 and 2 5 times. So it was observed that it took the magnet longer to fall in this experiment than falling in free space. And a possible source of error is the human error associated with recording the time it takes for the magnet to fall. So these are the results of the experiments. 5 trials were done and the time was recorded for the magnet to fall in each trial, and the average time was found to be 1.808 seconds. Next, a computational model was also made through GlowScript to indicate this in a computational sense. So the inputs were found of the physical constants, and the graph was initialized, and the geometry of the tube parameters were also included. And so this model then, creates the tube of aluminum foil as a series of rings stacked along the y-axis. And the bar magnet is also created and then visualized with initial conditions inputted. And the function is then determined to calculate the magnetic field, and then followed by the magnetic flux. And then a simulation loop is created, followed by calculations for the gravitational and magnetic force of the magnet and from the tube on the magnet. And then this is all, after calculating the current in the ring, this is all visualized in the end, which we can see here. And through this computational model, the time was found to be 1.761 seconds. So comparing both results, the computational result was, like I said, 1.761 seconds, and the experimental average time was 1.808 seconds. So the time difference between the models was 0.047 seconds. And additional sources of error are the magnetic dipole moment, as the actual value is unknown, and not accounting for other forces such as drag. So to answer the observational questions, red is found to be counterclockwise and north, and blue is found to be clockwise and south. Secondly, the magnet will still fall down slowly, but the blue magnetic field of the magnet in induced points will change. Next, the experimental time was found to be 1.808 seconds, and I apologize. Yeah, and the computational was found to be 1.761 seconds. And this difference can be attributed to the fact that the computational system does not account for air resistance, but it could be improved upon to do so. Finally, the sharp decrease in the beginning and end of the graph show that the gravitational force is larger than the magnetic force, and the straight horizontal line in between shows that these two forces are equal. So to answer some additional questions, to answer the first one, the answer is that the induced current and magnetic force would increase and the magnet would fall slower, and this is all attributed to Ohm's law, V equals IR. Secondly, the induced current would decrease, and Lenz's law would no longer be helpful in analyzing this observation, and the magnetic force would decrease and the magnet would then fall faster. Thank you.